Well, hello everyone, and welcome to today's webinar. My name is Chris Boomsma. I am CEO here at CAST, the Council for Agricultural Science and Technology, and I'm happy to kick off this third webinar in our series on FIFRA and ESA. This one is entitled Improving the Science Behind the Process, Implementing Better Data and Tools to Streamline the FIFRA ESA Process. Now, I have just a few comments for you before I hand it over to today's moderator and our presenters. So let's get started. First of all, I just want to point out that CAST is a 501c3 membership-supported nonprofit organization formed in 1972 as a result of the 1970 National Academy of Sciences report. We are proudly nonpartisan, apolitical, and unbiased, focusing on the science around particular issues. You can see our membership is a membership of organizations and individuals. And that's how we get much of our financial support for what we do here at CAST. And we are proud to be over 50 years in existence now, with our 50th anniversary celebrated in 2022. Here on this slide, you can see our mission and our vision. Just briefly, our mission: to convene and coordinate networks of experts. And you'll hear from some of those experts today around this issue. To do what? Well, to assemble, interpret, and communicate credible, unbiased, science-based information to a variety of folks, including policymakers, the media, the private sector, and the public. How do we accomplish this mission? Well, frankly, through the help of many, many volunteers. We have volunteers that come from academia, from government, from companies, from nonprofits. At any one time, we have many, many volunteers on our roster, and we are very, very proud of them, the great work they do. And you'll see some of the work that these volunteers have done for us today with this particular webinar and the essay attached with it. So at this time, I want to hand it over to Tony Bird, who's been here before, part of the FIFRA ESA webinar series that we're putting on here at CAST. And he's going to be the moderator for today, both introducing our presenters and also handling the question and answer period. So please feel free to submit your questions and we'll take it from there. Tony, thank you for being here, and I hand it over to you, sir, and take it away.
Yep. Thanks, Chris. Appreciate it. And as Chris gave a nice overview of CAST, I'll just mention that I am, as Syngenta's representative, I sit on the plant work group for CAST. And as we talked about projects and papers last year in 2023, as all of the changes in the Endangered Species Act have been happening over the last few years, we thought it would be appropriate to put something out with regards to ESA. And so initially I had approached Bernalyn McGahey, who is actually one of the chairs of this paper. And we quickly talked about what we could do with regards to writing up a paper for ESA, and then brought in Dr. Stanley Culpepper from University of Georgia, who's the other chair. Well, I can tell you it quickly went from one paper to a series of 6 papers. And for those of you who've been on the first 2 webinars, you got an overview of ESA and then a legal background. And this paper will focus more on improving the science behind the process, implementing better data and tools to streamline the FIFRA ESA process. And so our authors for this paper are Dr. Valerie Forbes. And Valerie is a professor in the Department of Biological Sciences and the dean of the Charles E. Schmidt College of Science at Florida Atlantic University. Specific research topics include population ecology and modeling, fate and effects, and of toxic chemicals in sediments, and ecological risk assessment. And Dr. Richard Brain, a Syngenta Fellow in the Strategic Sciences Department, focusing on, among other things, ecological risk assessment as it relates to FIFRA and ESA. So at this point, I will turn it over to Dr. Richard Brain, who will start the presentation, followed up by Dr. Forbes.
Thank you, Tony, and thank you all for participating in the discussion. My co-presenter has encouraged me to speak fast, so here we go. So this is not meant to be inflammatory in any respect, but in terms of the sophistication, the science that underpins the current ESA risk assessment framework has really not evolved consequentially in decades, despite significant advances in available science more generally. And so my co-author and I decided to tackle this subject for this CAST Symposium series. And so the Section 7 consultation process has already been covered extensively in a previous CAST webinar, so I'll only provide a cursory overview here. So pesticide registration in the US is governed by 2 primary statutes: the Federal Insecticide, Fungicide, and Rodenticide Act, as administered by EPA, and the Endangered Species Act, as administered by the US Fish and Wildlife Service and National Marine Fisheries Service, collectively the services. So when a pesticide is registered, that regulatory action must also be in compliance with the Endangered Species Act. Though there are some fundamental differences, obviously, in terms of protection goals, data sources, scope and scale between the two statutes. And when EPA determines a may affect, likely to adversely affect, they are required to enter into formal consultation with the services, who then evaluate whether or not the regulatory action is likely to result in jeopardy or potential adverse modification of critical habitat. And this creates, the interface of these two statutes creates essentially potential for non-compliance. For example, failure to consult or failure to assess, which creates opportunities for litigious intervention. So next slide, please. So the agency's preferred solution to this challenge, as laid out in the herbicide strategy, is to implement upfront mitigations to offset potential risks rather than advancing the risk assessment paradigm in a meaningful way. And this results in sort of a lack of calibration between the risks and mitigation. For example, if the risk assessment isn't of a requisite level of sophistication in terms of characterizing the risk in a more realistic way, it cannot adequately inform what mitigations are necessary and what the nature of those mitigations should be. And that could create onerous, and inappropriate and unnecessary mitigations for growers. And so next slide, please. The current process is essentially 3 steps. The first step is essentially a deterministic overlay of the crop use footprint with the endangered species critical habitat. Not surprisingly, this does not result in a significant screening of many species out of the process. The second step being largely a screening level assessment, albeit with some probabilistic components. And this essentially leads to a large number of species being then transferred to the services for evaluation of jeopardy and adverse modification, which occurs in the BO process, which is step 3. So if you go to the next slide, please. So auspiciously, the agency promotes a tiered risk assessment framework from very conservative and simplistic representations of reality up to very sophisticated experimental and modeling approaches. However, the biological evaluation rarely moves beyond the screening level tier. Next slide, please. So what are the obstacles to progress? Well, first, the most off-site obstacle would be resources, primarily funding and staff. Now, this could potentially be addressed by a more collaborative, multi-stakeholder type paradigm, for example, where industry funds or sponsors, research that's conducted by contract research organizations, academics, and then that could be vetted by the agency and third parties as well as NGOs. And we've seen this work, for example, for the physiologically based pharmacokinetic model that was developed in this manner. And is now being used routinely by Human Effects Division. So it is possible. And second, litigation, although effective at encouraging compliance, has brought ESA essentially to a standstill. And there is also a lack of alignment between the two statutes. For example, in the protection goals, under FIFRA, it's ensuring no adverse effects to non-target species, whereas under ESA, it's ensuring that listed species are not further impacted by any human-related cause. And the any human-related cause is interesting. And if you go to the next slide, the reason why we find this interesting is essentially that context acknowledging upfront is not within the purview of the Section 7 consultation. So we appreciate the fact that this is not part of the Section 7 consultation process, but we feel that this is an important element. And so it's important to ensure, because we want the best outcomes for listed species. For example, the species are, for example, if we look at the risk assessment process currently, if pesticides are a micro scale contributor to a macro scale problem, we're not effectively allocating resources to those activities that may be contributing more significantly to listed species decline. So it creates challenges for focus. And this is consequential because you want to ensure that whatever human induced or anthropogenic contributor to listed species, threats to listed species that we're identifying, which ones are most important, and putting them, rank ordering those in an appropriate way. So if you go to the next slide, so this is an analysis we did previously. This is essentially data that's been compiled by the U.S. Fish and Wildlife Service, primarily from LOSS, LOSS, and Pimentel, rank ordering the top human-caused threats to birds in the United States. And so the number one contributor to bird mortalities annually in the United States is domestic and feral cats, at nearly 3/4 of the bird mortalities, and a further 25% by collisions with buildings and vehicles. So collectively, these two account for 97% of all bird mortalities. Now, poisons, not broken out by type, household, industrial, agricultural, for example, account for 2%. And so, one may joke that spay and neuter programs are not covered under FIFRA, but they would sure be a lot more effective, in our opinion. So if you go to the next slide, similarly for mammals, you look at the top cause threats to mammals in the US annually, predation being number one, illegal harvest being number two, and nearly 10% caused by collisions with vehicles, which is grossly underreported because I'm sure you've seen innumerable squirrels and possums flattened on the highway that are never reported into the appropriate authority. And so, whereas if you look at, other human causes or cause unknown, they represent a much smaller fraction relative to these other factors. So if you go to the next slide, for fish, the primary threats are habitat degradation, obviously, and invasive species, but also in lotic environments, dams and impoundments are a primary driver. And so if you look at where pollution ranks relative to these other factors, it's actually quite low. You go to the next slide. So this is an ongoing analysis that we're conducting currently, where we mined essentially the recovery plans for all listed terrestrial plants and identified which factors are contributing most significantly in terms of the primary, secondary, tertiary, et cetera, as threatening the listed species. And not surprisingly, perhaps, nearly half of the primary threats to these species is invasive species, followed by closely by habitat alteration and development. And so of the 900 some odd recovery plans that we mined and evaluated, I believe there was 2 or 3 that identified pesticides as a primary contributor to listed terrestrial plant decline. So it's a matter of context. What is the relative contribution of pesticides to threatening the listed species relative to other things? And if we're so preoccupied with, for example, expending an inordinate amount of time and resource focusing on pesticides, we're not actually improving the status of listed species. So if we go to the next slide. Returning to the central theme, why hasn't the ERA process evolved when the available science has? Well, this is at least in part due to the highly prescribed nature of the current risk assessment framework, which makes it sort of inflexible for accommodating additional information, whether that's higher tier modeling, field studies, et cetera. And another useful question would be, what constitutes best available data? There is guidance available on that, but that requires discussion and agreement. To be honest, would a more collaborative multi-stakeholder paradigm address these obstacles? We certainly think so. And finally, there are multiple factors that contribute to species declines. And so how do we ensure that the optimal species outcomes relative to the variably contributing anthropogenic stressors? So again, if pesticides are contributing in a non-significant way in a relative context, are we doing a disservice to the species by focusing solely on pesticides in this context. And so, again, acknowledging that's not part of the current Section 7 consultation process, but something I think that is important for discussion and consideration. So if you go to the next slide, please. Here we are providing a few notable technical advances relative to endangered species assessment. And on the next slide, you'll see the automated probabilistic co-occurrence assessment tool. This is a tool that we've developed in collaboration with Stone Environmental. It's essentially a probabilistic framework that considers a joint probability of a pesticide being applied to a specific area, and then the likelihood of a listed species being present based on landscape features, habitat requirements, suitability, etc., essentially creating a species distribution model. And this is freely available. It's published, it's been presented to the EMPM meeting that's convened by EPA. And so, we feel like this is an example of something that could be adopted and integrated to provide a much more refined, higher tier level of analysis. And similar, if you go to the next slide, the pesticide mitigation effectiveness. So pesticide mitigation effectiveness can be assessed by the agricultural policy extender model. This was developed by the U.S. Department of Agriculture, where the outputs include pesticide field losses, nutrient losses from the field margins, runoff rates, etc. These can all be used to inform which mitigations are most effective, suitable, and appropriate. Again, this has been presented to the EMPM meeting convened by the agency. It has been published and it is publicly available. So that's a key element of these tools, is that they're publicly available, publicly accessible, completely transparent in terms of their development and execution, and everything's laid out in the public domain. And so you go to the next slide, which is my final slide. Another important element would be higher tier field studies, but not just higher tier field studies, higher tier studies in general. This can significantly reduce uncertainty and address and minimize risk paradigm assumptions. So this photo is essentially a field drift bioassay that we developed to address a paradigm issue with how non-target plants actually experience exposure in the field. Under the existing framework, the plants are essentially exposed to a direct overhead saturating application of pesticide. And then this is compared to a deposition drift curve that's generated by a model. And this results in very significant predicted buffers, because that is not actually how plants experience exposure in the field. So we came up with this design to fundamentally address that. But because it's a higher tier approach, the current screening level nature of the assessment does not accommodate this type of data. But this data is certainly available, and we feel like it would take a concerted effort from multi-stakeholder consortium to integrate this information, but it is possible. And at that, I'll turn it over to my co-presenter, Valerie.
All right, thank you, Richard. So switching from recent developments on the exposure side to developments on the effect side, I'm going to talk a bit about population modeling and traits-based approaches. Because the Endangered Species Act is really intended to ensure the long-term persistence of populations, the effects endpoints that we use ideally really need to be robustly connected to population level responses of species. And here's where population models have many advantages for ecological risk assessment. First, they can be developed for any species for which we have data, whereas historically, ecological risk assessment, ecotoxicology is focused on purely toxicological responses. We know that things like the life history and ecology of species matter a lot in terms of influencing their vulnerability to stressors. The population models can do a much better job of integrating spatially and temporally variable exposures than sort of standard testing techniques. And compared to higher tier field studies, one of the nice things about the population models is once you've developed and tested it appropriately, you can relatively easily and quickly test multiple different scenarios. more so than doing a brand new field study, empirical field study. And they're also designed to predict things that we care about, like the long-term population size, population recovery, size structure, etc. So given all these advantages, one might ask, well, why aren't they used as much as they should be? And if you could go to the next slide, please. I think there are several reasons that historically have been given for the resistance to using population modeling in ecological risk assessment, despite their long history of use in other branches like fisheries biology, conservation biology. One of in the US at least, one of the things that we've seen is there has been resistance by the regulatory agencies to move away from the traditional individual level effect endpoints and traditional methods that were developed back in the 70s, 80s. This maybe stems from a legitimate fear of litigation based on what we've seen so far. But I think that some of the developments that we've seen in Europe offer reason to be optimistic, and EFSA in particular has shown to be much more nimble in terms of modifying their approach to ecological risk assessment as the science has advanced, and in particular as the effect modeling has advanced. So that's one reason. A lack of guidance and standardization of population models has been given to historically as a reason for not using them, compared to, say, standard laboratory toxicity tests where we have all sorts of accepted guidelines. Lack of case studies has also been used as a reason for not using models. And then finally, a lack of biological data for many species. And I want to touch on the last three of these bullets in more detail. So the next slide, please. Whereas it used to be true that there was not very much guidance or case studies for population models, over the last couple of decades, there have been substantial advances in the science, starting probably with the overview design concepts and details, or ODD protocol, of Volker Grimm and colleagues, which was originally developed to help document agent-based or individual-based population models. It's now been improved through several iterations and is the most widely adopted approach to documenting population models that is really, I think, resulted in an improvement in their acceptance. Likewise, particularly for very complex models that predict patterns over large spatial temporal scales, it can be challenging to validate them completely. But developments in what's called pattern-oriented modeling, where basically the idea is if your model can reproduce multiple independent patterns in data, the more patterns it can reproduce compared to the actual real world, the more confidence one has in the model structure. More recently, we've been involved in collaboration with colleagues from the US EPA to develop guidance on model development, and PopGuide was recently produced in 2021. And this is basically a systematic, step-by-step series of questions and decisions that take a user, a modeler, through kind of a standard protocol to help determine what features can, should, and can't or shouldn't be included in a model. And it is designed to increase both the consistency of the population models, but also the transparency, and to make explicit not only those things that are included in your model, but what things aren't included in your models, which I think is also very important. And most recently, we've just put a paper that's going to be coming out in IEAM on standardizing conceptual model diagrams, which are often produced as pictorial summaries of population models, but there's been no consistency in the literature. And this is our attempt to sort of suggest a standardization. So again, like the ODD protocol, it makes it much easier for users or potential evaluators to assess what's in a model, what isn't there, and is it fit for purpose. Likewise, there is, over the last 10, 20 years, there's been a growing number of case studies demonstrating how population models can actually add value to risk assessment and particularly endangered species assessments. The first big effort was probably the CREAM, Marie Curie Initial Training Network out of Europe, which trained about 23 next generation of scientists with expertise in mechanistic effect models. There was a series of workshops in 2013, 2014 called Modeling, which was designed to bring together multiple stakeholders from industry, government, regulatory authorities, and academia to work through case studies showing how population models could actually work in practice to support, in particular, pesticide risk assessment. I also ran a couple of workshops out of the National Institute for Mathematical and Biological Synthesis, which developed case studies, in one case, population model, in another, an ecosystem model, to show how these models can actually add value to risk assessment and help us link from the kinds of things we often measure in our ecotox tests, which might be at the individual level or even below biochemical level or physiological level, to things that we actually care about, which are populations, communities, ecosystem services, those sorts of things. And then we've just, the POP Guide co-authors and others had published last year and a special issue in the journal Ecologies, which has a number of case studies showing how POP Guide, this new guidance on population model development, can work in practice with actual examples. And there are many more case studies that have been produced through individual research projects, and too many to report on the slide, and there will be more coming. Next slide, please. So one of the, I think, very legitimate concerns about modeling, particularly for endangered species, is we don't have data. And it is certainly the case that for many listed species, we have very, very little in terms of basic information on their life history, their ecology, and other details that one would need to produce a robust population model. So we've been working together with primarily colleagues from Syngenta to develop some trait-based approaches to allow us to help fill some of these data gaps. So basically, these are approaches that are species-independent ways of categorizing species according to various traits. These could be morphological traits, they could be ecological traits. We've been focusing primarily on life history traits to start with, mostly because we know that life history has a major influence on how vulnerable species populations are to stressors, and how those links from individual responses in survival, reproduction, growth translate up to impacts on population dynamics. The nice thing about the traits-based approaches, because they're species independent, they're more easy to transfer across regions and geographies. And instead of having to develop models for, 2,000 separate species, if we can group or categorize species into subsets, we may be able to reduce the number of models that we need to produce and analyze. We can also use the traits-based approaches to determine the relative importance of data gaps, what things really matter in terms of determining species vulnerability, and use that to prioritize efforts to fill those gaps. Next slide, please. So this is work in progress, but what we've learned so far with some studies that we've done with terrestrial plants, fish, and freshwater mussels is that the good news, there appears to be substantial overlap in life history traits of listed and non-listed species. And what this suggests is that we may be able to develop population models for data-rich, non-listed species that are useful for assessing risks to listed species where we don't have the necessary data. They can also be used, and this is a work in progress, to identify representative species that can represent entire groups and or represent particularly vulnerable species that we might want to model to ensure that our risk assessments are being sufficiently protected. The nice thing is we can use one model to represent multiple species by changing the parameters. An example here is dynamic energy budget models, which sort of take this approach, which again, it increases the efficiency and speed with which different models can be implemented and tested. And we believe that approaches like this, using traits-based approaches combined with population models, has the potential to help make the FIFRA ESA process more efficient. And work is still continuing. Next slide, please. So to conclude overall, by focusing only on pesticides, it's very likely that the FIFRA ESA consultation process is missing other important drivers of listed species decline. And I think several of the slides that Richard provided on certain taxonomic groups demonstrate this. I think it can be tempting to be proactive and put mitigations in place to meet compliance deadlines. But again, if these aren't sufficiently informed by science, they risk being either infeasible for growers, ineffective for protecting listed species, or both. And I think we firmly believe that as the science continues to advance, that the legislation and the process needs to advance as well, so that better science can be used to lead to better risk assessments and better decisions. And it's very likely that engaging multiple stakeholders in a collaborative effort to implement better data methods and guidance is a better approach that will help us balance the need for food production while ensuring species protection. In the immediate future, next slide, please. It could be very helpful to consider looking at the risks of pesticides in the context of other threats to listed species, so that we can make sure we are mitigating effectively and developing recovery plans that are likely to lead to greater protection of listed species. I think as some of the early biological evaluations demonstrated, we need to be able to use screening level assessments that are actually effective screens to remove low risk scenarios and focus efforts on where really the higher tier tools are needed to assess risk appropriately. I've already mentioned multi-stakeholder collaboration to get better science into the process, increase apparency, efficiency, and hopefully reduce litigation. And in the immediate term, it may be helpful to have the registrants provide data, methods, and tools that can be evaluated by transparent criteria, and to reduce the burden on both the EPA and the services, as is done in other jurisdictions and for other types of risk assessments. And I think that is the last slide. There we go.
Great. So thanks, Valerie and Richard, for that presentation. And just as a reminder, everyone, if you have any questions, please type your question into the Q&A box and we will answer any questions as they come. Should have also mentioned at the beginning that if we lose power on this, which we haven't, thank goodness, obviously we would have a different time to do the webinar. We're actually getting some Forrest Gump rain outside my window now. It's been going in different directions for the last 30 minutes. So hopefully everybody is safe out there in all of this different crazy weather that's going on right now. So again, any questions, please type it in the Q&A box. And so I will begin going through some of the questions for Valerie, Richard. Also, if you have any questions for Bernalyn or Stanley, please throw those in the Q&A as well too. So we do have one, Richard, and I'll kind of read it. It's maybe more of a comment and a question, but it says, granted that macro effects need to be evaluated as part of the pesticide assessment. However, how do the anthropogenic factors cause toxicity, cancer, fetal deformation, etc.? The picture is not complete without more complete models. climate alteration in temperature and rainfall will likely be an important factor. Just some thoughts.
No, I agree, and climate change is interactive with all of these different contributors to listed species decline. Obviously, it changes the range of listed species, it can change the homeostatic range of the listed species, can change the range of invasive species, that can contribute to multiple factors. And, I think it's important to understand, those adverse outcome pathways and, establish the molecular initiating event all the way up to, population level effects. I think that level of sophistication in a risk assessment is important, and that's where the pesticide risk assessment probably should be. But again, pesticides are just one component, in a much broader context of much more significant and consequential factors. And so, by virtue of focusing on one particular element that is not a significant contributor, relatively speaking, but is obviously mandated by law, we may be doing a disservice to the species because there are much more effective things that we could be doing, beyond the pesticide risk paradigm that would be greater significance in terms of listed species recovery and preservation.
So can I add to that? From a modeling perspective, I think, and in terms of the issue about changing temperature, rainfall, and maybe other stressors or other climate-related changes, I think this is where the modeling can be particularly helpful, because when you do sort of an empirical field study, the weather is what the weather is. To some extent, you might be able to apply different treatments, but it's much more difficult to have the type of control that you might like. Whereas in a computer simulation model, you can run multiple different weather scenarios, climate temperature scenarios, and run the model for, 20, 100 years and explore what the potential consequences of these other factors might be. And I see that as a strength.
Great, thank you. So I'm still monitoring questions, not seeing anything else currently. Here's another, okay, here we go. It's from Mark Bernards. It says, what would be the steps to change the review process by the EPA and the services to include some of the proposed models, studies that were discussed today?
I think this is not an issue that's explicit to endangered species. It also is integral to FIFRA, because it's basically fundamentally the same risk assessment process. And appreciating the fact that there are obvious pros to a screening level approach. It is prescribed. The endpoints tend to be consistent. It's efficient, but it's also not overly realistic. And so I think there's been efforts in multiple aspects of the risk assessment that some of them we touched on today that could be integrated, but that does require a fundamental shift in the nature of the risk paradigm, going from something that's more or less automated and prescribed to something that requires greater expert judgment and probably greater guidance in terms of the integration of these data.
So if I can add to that too, my own view and seeing where population modeling has been used in other types of ecological risk assessment, more on the FIFRA side or even on the ESA side of things, the way that they've been used to date is usually the models have been developed in an ad hoc manner, usually by the registrants as part of their higher tier package that they want to put in to the risk assessment. And so that means that there's no standardization. They're designed for a particular question, but at that point where you've got a specific risk assessment on the table, the stakes are high and it's easy to poke holes in the models and say, why is this in there? Why isn't that in there? My own view is what we need to do is kind of what was done to standardize laboratory toxicity tests. to get a panel, multi-stakeholder panel together to develop a suite of population models that everyone can agree on. How complex should they be? What should they include? What shouldn't they include? What species are we going to represent? And then get those accepted. And it's that sort of toolbox of models that would get applied under specific scenarios.
Great, thank you, Richard and Valerie. We do have some other questions here. So another question sort of following up on this is, how accurate are the mechanistic effects models? Will using them require a large safety factor? Not sure who wants to take that one.
Well, and that, in a way, it's an easy but not very satisfying answer. It depends on the model, right? I mean, we're talking about a lot of different models here, and I couldn't give you one particular answer. Oh, they're all accurate within plus minus 10%. I won't do that, but there are certainly ways to evaluate their accuracy. And ideally, no, they should not need a large safety factor. I think the whole kind of point is that we are incorporating some of those ecological, biological complexities mechanistically into the models that the, safety factors were originally designed to cover.
Okay, I'm not seeing other current questions. I don't know, as we wait for any other questions, I don't know, Bernalyn or Stanley, did you have any questions or any other comments to add to anything that Richard or Valerie have said?
If either of them or both of them could propose an integration that might be used, because of the litigation schedule, there's a time concern at the agencies for meeting deadlines. So how might we take advantage of tools as well as bring efficiencies to that process and introduce some of the things that you've been talking about?
I think nothing happens quickly, but I think one of the things that would be helpful if we return to, at least pre-COVID, we were having somewhat regular multi-stakeholder engagement sessions, and there was representation, from multiple entities. So obviously the registrants, consultants, obviously the regulatory authorities, NGOs, for example. And I think that dialogue and that interaction was helpful. And it seems like, there hasn't been as much engagement in that space or as much effort or emphasis put on those types of interactions and engagements. And so I think as a starting point, it would be useful to sort of reignite or reestablish, those types of dynamics so that, you can get everybody into a room, spanning from, the registrant to the grower and, everyone else, and sort of vet some of these ideas and at least start to chart a path forward, which we had been doing, but it seems to have stalled out.
Great, we do have some other questions here. As a follow-up to this, it says, are there models or methods from other geographies, example Europe, that could be considered here for ESA?
Yeah, I mean, most of the models, the population models that I'm familiar with are not geographically specific in the sense of their model structure. What would vary potentially geographically is how you parameterize the models, right? So let's say we talked about rainfall earlier. You might have developed a model with a particular rainfall scenario in mind. If you wanted to move that to another geographic area, you could implement a different rainfall scenario. That's pretty straightforward. I don't know if I'm understanding the question correctly, but there's been, because EFSA has been so, I think, open to considering models and have been involved in developing and improving the guidance I think we've seen more movement and development of population modeling approaches in Europe than to some extent in the US. There's been a lot of work on bees recently because those are obviously a concern. But I think the models that would apply under those circumstances could be applied in an ESA context. I mean, one of the things that Richard and I have been talking about and is in the paper, I mean, FIFRA is designed to assess the risks of pesticides on all non-target species, including listed species. So a question that I would ask as a scientist is, do we have any reasons to expect listed species to be any more vulnerable than non-listed species? And that's where some of the traits-based comparisons that we've done so far, it looks like, you know, certainly in the terrestrial plant species, there's no real distinction between listed and non-listed species in terms of their, you know, their population traits that would make them particularly vulnerable.
Can I ask a follow-on question to that of Valerie?
Sure.
That what you just said would seem to me to support the fact that a validated model would be, at least to the extent of knowledge gathered so far, would be useful for non-listed and listed species, or do you feel like additional data is necessary?
I think there are a lot of cases when a sufficiently validated model could apply. Let me give you an example where that might not be the case and where we're working right now. So we're doing a project right now in collaboration with Syngenta, looking at freshwater mussel species, a third of which are listed in the US. And there are some of these mussels, so what might make them particularly vulnerable is they have this fish host where the larval stage has to settle on fish gills and complete part of its life cycle in that habitat, if you will. Well, that's an extra habitat requirement that maybe, you know, other types of taxa don't have. And apparently some of the mussels are species, they don't care which fish species they settle on. Whereas others are, as I understand it, have to have a particular fish species host. Just guessing, I would expect those are more vulnerable because they're dependent on one fish species to complete part of their life cycle. So those are the kinds of biological nuances that we need to consider. But of course, we can use the models to explore how important is that part of the life cycle compared to everything else, because these species produce tons of larvae, most of which don't survive to adulthood anyway.
Great, thank you, Valerie. So we do have another question here, and I'm not sure if you can answer this question, but I'll pose it to you anyway. But maybe if we have someone from EPA on, maybe they could actually answer the question as well too. But it says, would incorporating population models require a change in interpretation of EPA's legal requirement to determine effects to an individual plant or animal? Or can the EPA shift from individual effects to population effects within the current FIFRA ESA regulatory landscape?
This is where, and you know, I'm not a lawyer, so take that for what it is, but I mean, this is where I always get kind of confused, because ESA is probably one of the few legal documents that's very explicit about protecting populations. And the 2013 NAS report that was produced to provide guidance on how this process could move forward explicitly recommended using population models for ESA risk assessments. I don't know, Richard, if you have more to add on that one?
Well, I think, you know, we're talking about one form of modeling, which is population modeling, but it's also important, I think, to acknowledge that the agency does currently rely on other forms of modeling, you know, exposure modeling, for example. So I suspect you could pose the same question more generically, Although, those decisions have been made with employing those other forms of modeling. So this, is just another form, and advancement of that, I think.
I mean, it seems the assumption is if you don't have any effects on any single individual, you won't have an effect on the population. So in that sense, it's an attempt to add conservatism into the process. But is that conservatism necessary? I mean, there are costs to that.
You have a few more questions here. Just a quick one. This was for you, Richard. It says, what did Dr. Brain mean when he was talking about higher tier studies?
Well, these would be studies that are beyond sort of the standard OCSBP guideline studies that are required for standard registration package for a pesticide. It's something perhaps more complex than that. I mean, microcosm studies, for example, used to be used routinely up until about 2005, 2006, but they suffered inherently from high variability. But, there are a number of higher tier methodologies, and it's not just field studies. The field study we did was to directly address what we thought was something that was paradoxical within the risk paradigm, which is the nature of how non-target plants experience exposure. And so we addressed that with higher tier method, basically to supersede, the current testing and modeling approach. So that's one example of going to the highest possible tier. We've also done stream cosm studies, to address uncertainty from more simplistic representations, as well as single species test data. There's also more sophisticated higher tier modeling approaches, watershed-based models, probabilistic tools that also fit within that purview, that are all available. It's just a matter of integrating them. And in order to do so, I think we have to become less deferential to the lower tiers, and which does provide the comfort of being standardized and prescribed, but also that requires a greater emphasis on expert judgment. And expert judgment should be based on guidance, and guidance should be vetted and discussed in a multi-stakeholder context.
Great, thank you, Richard. So we do have some other questions here. It's this one says the presenters mentioned that there are stressors other than pesticides. Can the proportional/relative impact of pesticides be teased out from the impacts of other stressors with some confidence using population models? Are adequate data available to build such models, and what more would be needed?
So a concrete example comes to mind, and this is Amelie Schmolka's model of the terrestrial plant Boltonia decurrens, which is the decurrent false aster. And she developed, it was an agent-based model of this plant, which lives in agricultural areas, but along riverbanks. And it apparently requires flooding. And so she developed an individual-based population model that looked at the relative importance of pesticides, where we had actual data provided by Syngenta, pesticide and herbicide and flooding and competition from other plant species. And she could use the model to tease those three things apart. And one of the take-home messages was, if these plants didn't get flooded on a regular basis to kill off the competition of the other plants, they went extinct, regardless, whether or not you had any pesticides in the system or not. And I think that was a very informative exercise.
Great. Still have a few more questions here. I'll try to get to a couple more. I'm not sure maybe who this question is for, and maybe Bernalyn, you want to answer this one, but has there been any attempt to discuss the information presented today to the groups driving litigation and timelines, or the judges involved, that EPA is subject to? From today's discussion, it seems the industry and agencies are being subject to timelines that are driving unscientific reactions to pesticide usage and endangered species management.
Well, I don't hear any other volunteers.
I would just make the comment that, yes, EPA is in an untenable position, that they have lack of people, lack of resources, and they are being driven by many of these court mandated deadlines that they must meet. So I have a lot of sympathy for EPA in the position that they're currently in. So
I agree, and I think we're all subjects to the unknown when it comes to managing the outcome of litigation. And I think there's a lot of agreement in the ESA world in general that the litigation pressure on that law makes it very difficult for the scientists involved and sometimes even the species managers involved to do the things that they'd really like to do or that they see maybe need to be done, but they're constrained by resources or diverted by litigation, and resources go there. So as far as talking to those that are involved in the litigation, it's done through the courts, largely. It's an adversary situation, so the courts have to decide where do we go. And I think it would be nice to have a forum where there's more neutrality, but unfortunately, the Endangered Species Act seems to be burdened by polarized positions, whether it's property rights or the kind of things we're talking about. And scientists, I think, can talk about it, but to get into a more abstract community, it becomes more difficult.
great, thanks, Bernlin. And have probably time for one last question here. And so I would just say it asks, to develop models on aquatic species, is there a precise definition of water? Research in different water sources can skew outcomes or at least unknown weights on outcome.
I'm not sure I understand that question. H2O, that's as precise as I can get. Richard?
Well, I guess you could handle it stochastically, right? I mean, in the models, we have ranges of parameters that are tested, which is representative of different systems. So part of it is just formulating the question of which species are you referring to, and that would dictate, the aquatic environment to focus on, and then how to, characterize that environment generically or specifically if you're looking at a site-specific example. And so, I mean, obviously, water quality varies depending on region, source, and subject to a myriad of factors, but those, can all be integrated in a model. I think there's bootstrapping methods where you could basically select from a range of parameters, or you could parameterize specific to, a given system.
Great, thanks, Richard. So we are just about the end of the time. I would just like to thank Dr. Forbes and Dr. Brain for their presentation, all the folks that attended and for the questions, for Bernlin and Stanley as well too, for basically coordinating a lot of this, great session. I will turn it over to Chris now, as he will have a couple slides just for the next presentations.
Yeah, thanks, Tony. Thank you to Tony as well. We appreciate you coming back, Tony. If you're not speaking, you're moderating. And thank you, Richard, Valerie, for coming this time. Just a few final comments here, folks. If you are interested in the paper, you can download it from the CAS website. You can see the QR code on your screen at this time. Simply point your device at it, and you can get right at it. Otherwise, just go to the CAS website, navigate there directly from your browser. So we hope you'll read the publication. Please note the next 3 webinars coming up. You can see the dates of each of them, January 30, February 20, and March 12. You can see the respective topics there. More details to come out in the next one as we get exact content specified and formalized for that one. But do please come back for the remaining 3 webinars in this series. Just want to point out something else that's happening here at CAS. We do have a new CAS paper rolling out here later this week. In fact, it's coming out at North Carolina State University. It's on RNA interference technology. So if you have an interest in that, please plan on attending. You can see some of the details on your screen at this time. You can also find details on social media, our website, and elsewhere. And there will be a webinar. So more information on the webinar to come after we have the paper roll out at North Carolina State. You can register for the paper rollout right there and also the webinar release. Again, we do like to use these QR codes. Hopefully makes it a lot simpler for you as you register for these events. So go ahead and register now after downloading the paper from today. And lastly, if you want to become a cast member, we certainly welcome you. You can see where individual memberships start at $35 per year. Student memberships are free. And of course, contact us anytime and do follow us on social media if you're so inclined. And with that, again, thank you, Tony. Thank you, Richard. Thank you, Valerie, Bernalyn, Stanley, and everyone else who's contributed to this essay series so far. And we look forward to welcome everyone back, hopefully, at our next presentation coming up in January. So take care, everyone. Bye-bye.